C'est à vous, monsieur HAQ. Donc le prix PRESTWICH, qui est remis en général à une personnalité étrangère, et donc ça c'était un vœu du conseil d'administration et de la commission de remettre le prix PRESTWICH, qui sinon est rarement donc remis, donc il faut un peu forcer les choses. Merci d'être venu. Donc ce prix, il a été décerné à Bilal HAQ pour différentes raisons. Alors je vous lis le compte-rendu de la commission. La Société Géologique de France a décidé de lui attribuer ce prix pour ses contributions remarquables à la stratigraphie, à la géologie sédimentaire et à la paléocéanographie, qui ont permis de stimuler une renaissance de la géologie sédimentaire avec des impacts majeurs sur d'autres domaines tels que la paléoclimatologie, la géologie historique, la géodynamique, l'analyse des bassins et la géologie d'exploration. D'ailleurs, l'utilisation mondiale des travaux de Bilal HAQ en tant qu'outil d'exploration reste primordiale. Qui n'a pas entendu parler des courbes de HAQ? Il est aussi un humaniste convaincu, défenseur du patrimoine donc géologique et grand ami de la France. Merci et félicitations. Je vous remets donc un diplôme et donc également donc une médaille à l'effigie de notre ami PRESTWICH. Et je vous laisse la parole.
Thank you very much. I think we'll keep the lights on for a while. I have a few slides later on because I want to thank lots of people and I don't want to miss anybody. It's indeed a great honor for me to accept the PRESTWICH Prize for 2019 from the Geological Society of France. My relationship with France is indeed an old one, going back to the late 1970s when I first accepted the invitation of Professor Charles Pomerol to spend a sabbatical at Paris University. I made many friends that included Professor Maurice Renaud, Gilles Audin, Yves Lancelot, Edith Vincent, Hugues Feinberg, Jean Mascal, and Jean-Paul Cadet. This was followed by an extended visit to SNPR, which is now Total, in Pau at the invitation of Jean and Charles Aubert, who I also count amongst my very dear friends. And to quote the famous words of Captain Louis Renaud in the film Casablanca, that was the beginning of a beautiful friendship with the French academia. This was renewed by another sabbatical in 2007, this time in Ifremer in Brest, where I made many new friends, including Serge Bernet, Gilles Laricollet, Marina Rubineau, Daniel Aslanian. This is also where I first met my good friend Christian Gorini, as well as Cécile Robin and François Guillochot from Rennes. In 2008, Cécile and François took me to a field trip, beautiful field trip in Presqu'île de Crozon in the Paleozoic, which I still remember. In 2010, I was invited by then president of the UPMC, Professor Maurice Renaud, on an extended visit to Paris, and I was appointed Professor Associé in 2011 at UPMC. Since then, at UPMC, now Sorbonne, I have collaborated with several colleagues and students researching topics in marine geology and paleoceanography. Sorbonne honored me with a doctor honoris causa in 2013, and I have made many new friends here that include François Baudin, Bruno Galbrun, Salah Boulila, Sylvia Yadin, Philippe Agad, Jeffrey Port, and of course, many graduate and undergraduate students. My fascination with France and French culture continues currently, and I currently spend several months a year interacting with both the students and the scientists at Sorbonne. Our most recent focus was on the Mediterranean deep basinal Messinian salt joint, which is a study that we just completed and was just recently published, and I'm going to talk about that in a few minutes. My early sabbatical in SNPR and current collaboration with Total and its researcher, especially Jean-Luc Rubineau, Jan Bauer, Remy Shah, and Rob Groot, has led to sharing of important data and ideas. It continues to be a very productive affiliation And we just published a breakthrough synthesis, as I said, on the Messinian salt giant. And this could help resolve many controversies about the Messinian salinity crisis and aid in the pre-salt exploration for resources in the Mediterranean. Once again, I express my gratitude to the Geological Society for recognizing my long-lasting, very happy association with France. My many close friendships keep bringing me back to France all the time. And to commemorate now, I would like to read a poem that I wrote here in Paris last year about exploration. And since we are all explorers and we all explore, I thought this would be appropriate to read this here. It's in English, but I hope you will give me a chance to read it to you. In awe of my fellow explorers, meaning you, I journey through my own mind and find hidden places unvisited, sounds and sensations unknown, minds, landscapes unexplored, where now I yearn to amble through, discovering obscured vistas for the first time, eager as a precocious child. Traveling through the somatic was enriching, but this inner exploration keeps bringing me back to where I began, and I surprise myself. With every insight, I become more seeking. With every new find, I find more of myself. Enigmas waiting to be decoded. With every solution, I seem reborn. A child in China looks me right in the eye and asks, "Mr. Scientist, in your journeys around the world, what have you found? Have you discovered God at last?" I am at a loss. Such weighty question from one so young weighs me down. Notion of an ultimate find baffles me. I stare back at her and ponder. The most revealing journey I undertook was into the inner space inside the microscopic world of the unseen, where you find nature's plans and hidden troves, where you see the architect in action, creating, destroying, recreating, and discarding with a blueprint to arrive at a near perfection, but nay, never an outcome that cannot be bettered. Nature cannot help but persist in its never-ceasing experimentation towards greater harmony, loftier beauty, evolving mere rocks into nobler forms. Now, keen to voyage into myself, my introspection has its own reward to let me see clearly that I am a part of nature's plan, the grand scheme that holds it all together, making particles move with the precision of a magical clock, allowing variance, but just enough to keep us an ever-interested lot. Our awareness comes with a prize, for each insight inflates nature's circle of secrets that renders incomplete our own never-ending quest to unmask the mysteries beyond the visible light. Could this be man's real raison d'etre? As a part of nature, we are a part of creator and creation, and comprehending nature and hence ourselves should not be our most sacred call. Perhaps I have answered the child's innocent query after all. Thank you. And now, I think you turn on the slide there. A few words about the project that we just finished. We'll need to turn on the slides here.
Please wait a minute.
J'ai cherché le clavier, moi, il n'y a plus de clavier.
Il est là.
Non mais c'est bon.
Tu peux nous mettre sa présentation? Ah, monsieur HAQ. Ah bah, ils ont mis la clé sur le...
The deep Mediterranean. Yeah. This, yeah. Okay. Thank you. Thank you. Okay. The Messinian salinity crisis is something I'm sure you're all familiar with, because there are many, many French scientists that have been working on this particular topic. Not only French, but also lots of Italians, Germans, Dutch scientists, and so it means and of course also American scientists who have been working on this thing since the 1970s, and there are thousands of papers that have been written on the Messinian salinity crisis. There is one big difference though. All the studies that have been done from the peripheral basins of the Mediterranean, and the deep basins remain more or less unstudied except for a very top veneer where the scientific drill has only been drilled to the upper veneer of these sediments and never right through the salt. So this is something that has been missing, and of course there is one way to solve this problem, and that is to look at all the seismic data, because seismic facies analysis allows us to determine the volume and the thicknesses of these salt and salt-bearing sediments in the deep basins. And of course, in the academia, we did not have this data, but fortunately in the industry, there is lots of data, good 2 and 3D seismic data that in their coffers, and our wonderful collaboration with Total allowed us to actually convince the management there to let us look at this Messinian interval through the entire Mediterranean and each individual basin, and determine the thicknesses of the salt. Because when I was looking at this issue, all the controversies that exist, together with Christian, we realized that we cannot solve many of these problems, many of these controversies, before knowing how much salt there is in the deep basin. A fundamental issue that has never been looked at because of the lack of data. Thanks to Total and our collaboration with Total, we have been able to now determine exactly that. Now, one issue that is probably not realized by many people is that this was not just a Messinian salinity crisis when almost 5% of all dissolved salt from the world ocean was removed and sequestered in the Mediterranean. It was totally removed forever from the world ocean and sequestered. But it was also an erosional crisis, a major erosional crisis. And here you see a figure that Christian put together, and you can see in the eroded volume of Western Mediterranean, a huge amount of sediments were eroded from the shelves and slopes and redeposited in the lower parts of the slope as well as in the basins. So it was also an erosional crisis as well. And so the results of this study, which has been going on for the last couple of years now, were actually, the study was finished last year in October, but it took us a long time to get all the permissions from the various companies and so forth, whose data we are using, to finally it came out and was published online in October in Global and Planetary Change. As I said, this is a major breakthrough paper, because now you have statistics which the community can use to sink their teeth into and then solve many of these controversies which could not be resolved before. Okay, the data availability to us was, of course, it's an active area of exploration, so the companies are not willing to let us show all the lines, but they allowed us to show the density of the data that we have used. And as you can see, the data is adequate almost all over the Mediterranean. In some places it's more than adequate. It's a very rich data, the dark spots as you see. And then the black lines are the lines we are actually allowed, we got permission to show them in our paper as our examples of our study. But we used all of this data. In addition to this, we also used all the borehole data, both academic and industrial boreholes. We had 3 additional boreholes that were not available before from the industry. And so we have used all of these boreholes. I must remind you that most of them, 99% of them actually do not go through the salt. And there are only 2 holes now that actually go fairly down into the salt. Otherwise, just the upper veneer of the salt. So the study is based on seismic facies analysis, where you can easily recognize salt facies, pure salt facies, and mixed facies that are mixed with the salt. And you can, of course, recognize the erosional services that are associated with the Messinian salinity crisis. And to keep it manageable, we divided the Mediterranean into 3 parts, Eastern, Central, and Western, and they're very different in tectonic evolution and character. There's lots of sediment piling in the Eastern Mediterranean, which is less in the Central and even lesser in the Western Mediterranean. And as you will see later on, they are very different parts, ocean, sorry. Very different basins. So here is the results of all the calculation, and as you can see, we have calculated the proportion of salt versus mixed layer. Mixed layer means sediments plus salt. Now, when I say salt, it doesn't mean sodium chloride or rock salt. It also means anhydrite as well as gypsum and gypsum anhydrite and salt all together. Most of it is salt, lesser amount is anhydrite, and even lesser amount is gypsum in this equation. So that is mixed with and then this is the pure evaporite, this is the mixed layer proportion in each basin, and as you can see, we have looked at each individual basin in these 3 subregions, and then we've calculated these are the velocities used based on the amount of sediment mixed with the salt, and then these are the thicknesses calculated on the basis of that, converting time, two-way travel time to thickness, and then here is the volume calculated for salt plus mixed layer, and then we separated the salt from the mixed layer, and here you have minimum salt, maximum salt percent, and the total volume of the salt. This is the final calculation. And as you can see, total volume of salt plus sediment is about 1193.2 thousand cubic kilometers, and just the salt itself is anywhere between 820 and 927 cubic kilometers in the Mediterranean. So now you have these statistics that you can sink your teeth into, and the community can continue working. It's a real step forward in that sense. Here we produced these isopac maps. There are lots of surprises. People who work on the Mediterranean have already commented that they see lots of surprises in these maps. And for example, the piling up of sediments, here you can see that normally sediments are between 2 to 3 kilometers in the deep basins, but they have piled up to more than 4 kilometers. In fact, in here somewhere there are 6 kilometers of salt that are piled up by tectonics. There are other areas, sort of, actually, what happened here? The salt thicknesses follow bathymetric trends in general in the Mediterranean. And so here is the results from the central Mediterranean. The Tyrrhenian Basin is also in the central, but it's not included in this map. You'll see it in the next one. And as you can see here, very little salt in the Sirte Basin, but a lot more in the Ionian Basin, and it's quite thick in some areas. And then this is the Western Mediterranean. As you can see, there are lots of surprises here as well. This is one that in France people have been working a lot on the Ligure Provençal Basin, and of course a lot of these results are brand new. Algerian Basin, we knew nothing about the Algerian Basin, which we now know quite a great deal, and also the Tyrrhenian Basin here. The study, I should point out, does not include the basins that were perched higher than the deep basin, like the Adriatic was perched higher. There is a small amount of salt in the Adriatic, and of course also the basins in Morocco, Spain, Italy, Sicily, Greece, and those places. Those are all perched higher, and they are not included in this, but those are supposed to be something like 5% of the total amount of salt. So there is very little amount of salt in that. Most of the salt is here in these basins. So okay, so that's in a gist of what we are showing, and here is a complete Mediterranean map. And as you can see, the perched basins are not included here, but all the deep basins are covered. And implications are quite obvious. The results have important implications for Messinian Selenic crisis event and its controversies, as well as for subsalt exploration. Total amount of pure evaporite that has been estimated, which is this amount, equals to 7 to 8 times the modern equivalent of Mediterranean saline water sequestered in the deep basin. What does that mean? It means that if you take the present day water in the Mediterranean and dry it completely, you will have to do this 7 to 8 times to produce the amount of salt that we see in the Mediterranean. It's a mental exercise. It doesn't really mean anything, because the Mediterranean, there are several models of how the Mediterranean salt was deposited. We don't discuss that in any detail in this paper, but we are working on that now. And that, as you can see, the last item in the this thing says that we are still working on implications of these events. And thank you very much. This is a very good example of collaboration, my collaboration with both the French academia and the industry. Thank you.
Some questions?
You did work with the time isopac from interpreted sections, and you mentioned briefly some velocities. Did you use one single velocity per sub-basin before preparing your isopac in meters?
Yes, depending on the amount of proportion of salt versus mixed sediment. It will differ. If it's all pure halite, then the velocities will be different than if it's all pure sediment. And then if you have different proportion, it will affect the velocities. So you get an average thickness and volume estimate from that.
And the velocity model we can add comes from the geoposition of the dome. These are not.
Yeah. So these are actually either they are ground truths by actual velocity information that was gathered during the drilling or during the seismic work, or they are models of. So there a lot of thought has gone into selecting the velocity, because that really affects all of your data. So we have to be very careful.
No questions? All was clear. Oh, yeah. Thank you very much.
Thank you.